It's the Star Wars screen. All right, so let's go ahead and take a look at these most missed concepts. So you have to know that about 80% of the periodic table is metals, right? So all of this is metals. Even these down here, the anthanide and lanthanide series, we didn't go over them because you don't need to know much about them. They're very common. They're very alike metals. They're supposed to fit right here, but we put them down there so the periodic table isn't so long. Okay, but those are all metals. This little, and that little sliver is not metal, and then the yellows aren't metals. Okay, so make sure you know that the majority of these, all of these, are metals. Left side and to the middle. Make sure you know group 18. Now, somebody came up to me while we were taking the exam and said, I thought we only had groups and periods. What does a column mean? A column is the same thing as a group, right? So we can call them groups. We can call them columns. We can call them families. They all mean the same thing. And you've learned about 4 of them. And one of them is the noble gases. What's important about the noble gases? Who knows what's important? Yeah, they have 8 valence electrons, which makes them what? The only what kind of stable? The only naturally stable elements are the noble gases, okay? Because they have already complete outer shell. That is what all elements are trying to do, become stable. That's their ultimate goal. And since they're already stable, they don't have to do anything. That's why in our story, they were the king just sitting in his castle because he's already reached the pinnacle of what he can be. You have to know about the semi-metals. The semi-metals. Does anybody know the one semi-metal I asked you to remember? It's the most important because it's in all of your electronics. Silicon, and it's right here. Si. That's silicon. Silicon is probably the best semi-metal that you need to know, not only for this exam, but for the future moving forward. Okay? Now, semi-metal is because it has properties of metals and properties of non-metals. Now, it's a good conductor of electricity. It's not the best conductor. The best conductors are the metals. But it's a good conductor of electricity. But it's a poor conductor of heat. So that means you can run tons of electricity through it and it won't overheat right away. That's why they're good for computers, because you can keep them at a lower temperature. Acceleration graphs are still throwing people off. And that's fine, because this is one of the hardest parts of the year, is that Unit 1 stuff. That's why we do Unit 1 stuff at the very beginning, so that we can go through it after every exam so we can keep up with it. Remember, you have to look at the y-axis. The y-axis is what you need to be looking at. The y-axis. So make sure that you're looking at it. The y-axis is showing us on this one that we're looking at position. We can also call it distance if we wanted to. So that's telling us how fast. So that's a speed graph. Okay? And on a speed graph, when the lines are going straight up like this, that means they are speeding up, right, at a constant speed. So these are all constant speeds. Okay, this is like 20 miles an hour. This is like 50 miles an hour, and this one is like 80 miles an hour. So you can picture a VW Bug, a Honda, and a Lamborghini coming right off the line, okay? But they're all traveling at constant speeds. Now, for an acceleration graph, that's speed over time, a line going up like this, that means you're speeding up, okay? This is constant speed. This is speeding up. So if I said, what car is speeding up? Well, which graph shows a car speeding up? Acceleration graph, because it's showing it speeding up. Now, remember, a flat line on this graph means constant speed. A flat line on this graph means stopped. That means you're not moving anymore. A straight down line like this, okay, a straight down line like this means slowing down. There is no such thing as a straight down line on this graph. Can't do that. If you want to know speeding up, remember it's the curve, the line pointing up, and slowing down is a curve with the line pointing down. That's speeding up and slowing down. Just make sure when you see graphs, the number one thing you look at is the y-axis first. Ionic and covalent structures. On the exam and on your quizzes, you said that a crystal was regular repeating patterns. That is correct. But you all circled, well, not all of you, but a majority of you circled regular repeating patterns of covalent bonds. That is not the case, because our number one example of a crystal is salt. And salt is made from the ionic bond of a sodium plus ion and a chlorine minus ion, creating sodium chloride, which is salt. Crystals are regular repeating patterns of ionic bonds. Okay, so make sure you understand that. Ionic bonds. Now, you don't have to worry about this at the moment, but on Unit 5, we're going to end the unit on organic chemistry. And all that means is the chemistry that's in living things, how things work and why we need vitamins and stuff like that. And polymers are the main thing in our body that make, which are called proteins. Okay, and proteins pretty much keep you alive every single second of your life. But they're made from regular repeating patterns of covalent bonds. Okay, so that's what a polymer is. So we're not talking about that yet. So make sure you click on ionic bonds when we're talking about a crystal. We're still not understanding the particles and how it's represented on a graph like on a model like this. If I was to ask what is the atomic number of this picture, what would you say? 6. The atomic number is the proton number. What if I said, what's the weight? 12, because it's 6 plus 6. What if I said, what element is this? Carbon, and it says right there, carbon. Okay, but it's atomic number 6, proton number 6, so it's element number 6, and that would be carbon. So make sure we understand that. Now, if I show you a comparison, what is the very first thing you look at when I show you a comparison of two elements? You look at protons first. What if the protons are different? What do you have? Different elements. And then the question's over. You look at protons first, and if they're the same, you move on to the next option. But if they're different, the question is over. You're instantly going to choose they are different elements, because that's what it means when you have different proton numbers. They're the same. So what do you think the second particle is that we look at? The neutrons. So the second thing we look at is neutrons. This one has 6 neutrons. This one has 8 neutrons. So what does that mean? Same number of protons, but a different number of neutrons. What are we looking at? What are we looking at? Nope. We're looking at the atomic mass. The mass has changed, absolutely. But if it has the same number of protons, but a different number of neutrons, what do we call that? An isotope. Okay, same number of protons, but a different number of neutrons, we call that an isotope. Make sure you understand that. We call this carbon-12 and carbon-14. So what if I said carbon-14 and carbon-12 are isotopes of each other? What is the difference between carbon-14 and carbon-12? What are some things you can say? You can say the neutrons are different. So how are the neutrons different between carbon-12 and carbon-14? Carbon-14 has 2 more neutrons. What else can you say? It's heavier. Carbon-14 has more mass. Okay, make sure you understand that's what that number means when I say it after an element. Okay, those are a couple things that you can say when you're looking at isotopes. Now, let's say that they both have the same number of neutrons. Now we don't say isotopes. Now what do we look at? Electrons, right? And so the question is, are they neutral? Well, let's see it. Remember, neutral means you have the same number of protons as electrons. So we have 6 here, and we have 1, 2, 3, 4, 5. Whoops. There's 5 electrons, but only 6 protons. Is it neutral? Is there 6? No, there's 1, 2, 3, 4. Yeah, there's 6. You're right. So there's 6 protons, 6 electrons. Is it neutral? Yes. Neutral means it has the same number of protons as electrons. What if the electron number is different? What do we call that? The same protons, but different electrons. What do we call that? An ion. Now remember, there's plus ions and minus ions. Okay, and we call them cations and anions, but you don't have to know that at the moment. Okay, the plus means there's more protons. So if I say plus 2, that means I have 2 more protons than electrons. If I say negative 2, that means I have 2 more electrons than protons. Just remember, the proton number can't change. So look, this one has 6 protons and 1, 2, 3, 4, 5, 6, 7, 8 electrons. 6 protons, but 8 electrons. Is that considered neutral? No, because there's different numbers. So what is my ionic charge? If I have 6 protons and 8 electrons, what would my ionic charge be? Negative, because electrons, there's more electrons. So I put negative. So I know it's going to be negative. Negative by how many? Remember, it tells me how many more electrons do I have than protons? 2. It'd be negative 2, because I have 2 more electrons than protons. That's all the negative 2 means. I have 2 more electrons than protons. All right, so make sure we understand all that. Density. This was another one of our most missed questions still. Density. It shouldn't be. We should know that the equation for density is what? M over V. So all we have to look for is mass, which is designated by which unit? Which unit do we know that it's going to be a mass? Gram. So I look for grams. Okay, so let's go through this question, and it says an object has a mass of 10 grams. Well, that instantly goes on my top number, 10 grams. And now we look for volume. It doesn't give me an exact volume, but it does say that water starts at that place and ends up at this place. How much did it go up? 50. That's it. That's our volume. What do we call that when it goes from that place to this place? Displacement. That is your volume. So 50 goes on the bottom. I don't know why that line keeps disappearing. There we go. 50 goes on the bottom. Now it's a big number, a small number divided by a big number. So what do we know it has to be less than? 1. It has to be less than 1. Okay? And if I take off my zeros, it's 1 divided by 5. That's 1/5. And so that's going to be 0.2. Okay? 1/5 of $1 is 20 cents. So it's 0.2 would be my answer. That was one of the most missed questions on the exam. Was a very simple density equation problem. One of the other most missed questions on the exam was the very simple isotope comparison, right? Like if I said oxygen 12 and oxygen 14, what's the difference? And we said, 14 has 2 more neutrons, or 14 has more mass. That's one of the most missed questions, was one of those simple ones like that. This was another one of the most missed ideas. Was the way that gases and liquids and solids act, right? And I asked you to write down from the starter number 9 everything so that you would never miss these questions. You have to know that in a solid, you have the highest attraction and lowest molecular motion. That means kinetic energy. Kinetic energy is the same as molecular motion. Since they're so tightly packed together, they're not moving much. They're vibrating in place. They're not moving much. Highest attraction, lowest molecular motion. Liquids, they do move a little faster, but they don't move the fastest. Okay? They do have higher kinetic energy, but they don't have the highest kinetic energy. And they have weak attraction. So we would say low attraction. And then gases, they have the highest kinetic energy. They're the ones that are moving the fastest. And since they're moving the fastest, they are the ones that are most likely to collide and bump into one another. Think of if you have just like tons of cars on the road and there's no directions anymore, right? There's no left, there's no right. It's everyone for themselves. There's going to be a lot of cars crashing into one another because they're moving super fast. Okay, so that one has the highest kinetic energy, but the lowest, or actually zero, attraction. And you have to know the way to get from one to the other is by adding what? What do you add to go from a solid to a liquid? Heat. What's another word that we've used for heat? Thermal energy. TE. Thermal energy. That's another thing that we forgot. Okay. To go from solid, liquid, and gas, we add thermal energy. To go from gas to liquid to solid, we remove thermal energy. Remember, there's no such thing as cold. All there is adding heat or removing heat. There is no such thing as cold. Cold is your body having the sensation of your body losing heat. And the more rapidly it loses heat, the more you get the sensation of the idea of cold. But there is no such thing as cold. Only the addition or the removing of thermal energy. Another one that we missed real quick is a question about velocity. What are the two things that velocity has to have? The two things that must be in a velocity vector. A magnitude and direction, right? And in the term of velocity, what's our magnitude? Speed plus direction. So if you want your velocities to be the same, both of these have to be exactly the same. So if I say a car is going 50 miles per hour north and another car is going 50 miles per hour north, would the velocities be the same or different? Which one? Same, because both of these, speed and direction, are exactly the same. What if I said one car is going 50 miles an hour north and the other car is going 50 miles an hour south? Are they the same velocity or are they different velocities? They're different. Why are they different? Because the directions are different. If you want the velocities to be the same, both the speed and the direction have to be the same. If they're not, then it has to be different. That was another most missed concept on the exam. Okay. Are there any other questions or any concerns you want me to go over before we move on? Yes. So now remember, the object's weight is basically gravity plus your force. So weight is a force pushing down. Okay. And buoyancy is a force pushing up. It's basically an opposite tug of war, right? Instead of going left and right, we're going up and down. So the only way for something to float, the only way for something to sink is if your weight wins. So if your weight is greater than gravity, if your weight is greater than buoyancy, you sink. Every other situation, you float. So if buoyancy is equal to your weight, you float. If buoyancy is greater than your weight, you float. Okay. The way we say it is an object will float if its buoyant force is equal to or greater than your object's weight. Or you can say the displaced fluid, okay, of an object. Who can help that? How are the elements arranged on the periodic table? What happens as you go from left to right? The proton number increases. Okay. The number one missed version of that was, guess what? Guess what the number one missed answer on the exam for that question? The right answer was the proton number increases as you go from left to right. Guess what the number one missed opportunity was on that one? What did they think increased? The mass. And that's the way they used to arrange them. But we now know that since there's lots of isotopes, the mass can change. And since mass can fluctuate, you cannot go by that. You have to go by what doesn't fluctuate, and that's the atomic number. Any other questions before we move on? Okay, so hopefully we answered all the things that you were kind of teetering on. Hopefully we get a lot more 100% on this one. So go ahead and put everything away except your notes and your periodic table, and I will come around and hand back your answer document.